Hi guys. So what's going to end up happening here is I am walking you through the last part of chapter 10, which is that condensed packet that you guys already have. So this slide right here is something you guys already have. If you flip to the back of what we've been doing the last couple days, our first big topic in this lesson is looking at two types of data. We have paired t-tests versus two sample t-tests. Now, paired tests are something we learned about last chapter, back in chapter 9. And a paired data set can be described as the mean of the differences. So fill this out as we're going through it right here. Mean of the differences. It's really helpful to have an example to kind of wrap your head around with this. And we did an example of that last chapter. It was our shopping example. So if you remember, what happened is there were two girls and they would enter the shopping lanes, the express lane and the regular lane, at the same time. And they would see who got done faster when they ordered the same or bought the same items. So what we did in this problem is we took the express time minus the regular time and we got a difference. So for example, my first difference right there would be a difference of -5. And I would do that for each of my data points right here. And what I did then is I analyzed the mean of the differences. I found the difference for each row and I analyzed the mean of that, and I would compare it to 0, if you guys remember from last chapter. This data set is paired. It is paired because each set of data points right here is very much linked together. The girls entered the shopping lanes at the same time. So each data point over here corresponds to an exact data point over here. The best way to remember or be able to tell if something is paired or not, if you scramble up a list of numbers, will it matter? In a paired data set, if I were to scramble up this column of numbers right here and just mix those all up, I will have ruined my problem because these numbers are the girls going in at the same time. So if you scramble your data and you ruin it, it is a paired t-test. On the other side of things, where a paired t-test is the mean of the differences, a two-sample data, which is or two-sample t-test, which is what we did last time, is the difference of the means. And an example of that we talked about was generic cookies versus Chips Ahoy, how many chips were in each. If you look at your data set over here, I have generic cookies and I have Chips Ahoy cookies. I do have numbers that are lining up right here, but these numbers aren't linked in any meaningful way. This just happened to be my first generic cookie. This was my first Chips Ahoy cookie. But if I took my Chips Ahoy numbers, for example, and I mixed them all up, I would still be okay. It's not the fact that this number goes directly with this number, it's just how it worked out. So if you can scramble a list and still be okay and not have ruined your problem, you're looking at a two-sample t-test instead of a paired t-test. So that is how you can keep the two straight. And my little videos right here, I'm kind of capped at 5 minutes a piece. So I'm breaking them into bite-sized pieces. I want to look at two lengthier new examples and talk about which type of data they are. So in my first problem, if you read that for yourself, basically what's happening is we had a 2-day period and we were looking at some sort of test for, it looks like depression in this problem. And we wanted to know the difference between a caffeine capsule. So in one group, oh, got a weird crayon thing going on right there. I had a caffeine, and in one group I had a placebo. And what I did is I compared the scores that they got with normal and with caffeine and with placebos. Okay. But the key here is that it is going to be a paired data set because each person did the placebo, each person did the caffeine, and I compared each person's ratings. It's the same person for each who did each thing. So in this problem, if I were to go ahead and scramble up a list of numbers, I'd be ruining each person's data point that corresponds to itself. I can't just scramble them and be okay. On my second example right here, I've got two different groups. This time it's calcium and placebo. I have 10 people who got a calcium group supplement, and I have 11 different people who got a placebo instead. And what I'm going to do is compare the two groups. But each person in the calcium group doesn't correspond. It's not the same person with the placebo, or it's not a matching person. These two data sets are, for all intents and purposes, just different groups of people. That would make this a two sample instead of paired data. I can scramble a list and still be okay.